Hi guys, welcome to a lesson of ordinary differential equations. In the previous class, we discussed about the homogeneous ordinary first order differential equations. Now we are going to talk about equations that are reducible to homogeneous forms. So actually, we will see that the equations are not homogeneous, but we can transform them to homogeneous forms by using substitutions, right? So let's see the idea of transforming the equation. So assume that an equation of the type is given, that is ax plus by plus c over ax plus by plus d, right? So we can see that due to the presence of these constants, this equation isn't a homogeneous equation. But what we can do is we can just substitute x is equals to x plus h, and then y is equals to y plus k to eliminate these constants. So see how the method works here. Now dy over dx will be transformed to the capital Y over the capital X, which will be equals to a times x plus h plus b times y plus k, and then plus c over a times x plus h plus b times y plus k plus d. And now rearranging the equation, we can write ax plus by plus ah plus bk plus c divided by ax plus by plus ah plus bk plus d. Now say this is equation number 2. Originally we have equation 1 that was this kind of equation, and then we use the transformation, use the substitution, and we transform the equation. Now what we have to do here, we just have to use these constants here, and if yes, we can see here that if we eliminate these two values, then we will left with ax plus by over ax plus by, which is a homogeneous equation. So now what we can do is we can just equate these constants with 0 from the numerator and from the denominator, right? So equals to 0. Let's call it equation 3 and call it equation 4. So where a, b, c are constants, a, b, c, a, b, d. These all are the constant that will be given in the original equation. But for h and k, we need to work out, and we can use these two equations to solve for h and k, right? So we will solve these equations simultaneously to find h and k. Now this will, when we will find the values of h and k and plug back to the equation number 2 in this equation, then what we will get this one 0 and this one 0. Therefore we will left with only these two equations, right? So then the equation will be homogeneous. Now let's take an example for practice. Say question is given, dy over dx is equals to x plus 2y minus 3 over x 2x minus y plus y minus 3, right? So fortunately that this and this constant is equal, but it's not obvious that this is equal, not always equal, right? So it may be any constant like here -3 here, 5 6 or -7, and right like that. Now, first of all, we are going to use the transformation substitution, that is x is equals to x plus h and y is equals to y plus k, right? And we will put into the equation, so we will have dy over dx is equals to x plus h plus 2 times y plus k minus 3 divided by 2 times x plus h plus y plus k minus 3. Right now we will rearrange the equation. Dy over dx is equals to x plus 2y plus h plus 2k minus 3 divided by 2x plus 2h, or we can write here y, and then we will write h plus 2h plus k minus 3. All right, so now what we have to do is just take these two constants and equate it with 0. So to find the value of h and k, right? So it will be -3 is equals to 0. Now we will solve these two equations to find the value of h and k. So simply we'll solve it simultaneously and we will get h is equals to k is equals to 1, right? Now plug these values in this equation. What we will get if we will put 1 here, if you will put h is equals to 1 and k is equals to 1, so it will be 1 plus 2 minus 3. So this part will become 0, right? And again for this one, this part will be also 0 because 2 plus 1 minus 3, right? So now we will left with only x plus 2y over 2x plus y, x plus 2y over 2x plus y, where this is equals to dy over dx. Now we can see that this equation is a homogeneous equation. All right, so now again we will use the similar substitution that we used in the homogeneous equation, that y is equals to ux, which implies that dy over dx will be equals to u plus x du over dx. All right, so substitute in the equation. Let's say it's equation 1. So 1 implies that u plus x times du over dx is now equals to x plus 2ux over 2x plus ux, right? So x is common all everywhere, so we can cancel these x's. So we will left with x du upon dx is equals to 1 plus 2u over 2 plus u minus u. This move this u to the right hand side and this will be -u, right? So this is 2, this is 2, right? Now they take the LCM, so we will get 1 plus 2u minus 2u minus u squared over 2 plus u. Now by simplification, let's shift this 2 plus u over 1 minus u square with du, because now it's separable, and dx over x. Now this equation is solvable. We can solve this equation by using partial fractions because it is 1 minus u squared. So if we make partial fractions of this equation, uh, I will assume here that you know how to solve the partial fractions. So it will be 1 over 2 times not 1 over 1 plus u minus 3 over 2 times 1 over 1 minus u, right? So now we can write here 1 over 2 times 1 over 1 plus u du and minus 3 over 2 integral 1 over 1 minus u du, which is equals to dx over x. All right, now we are going to simply integrate, so we will get 1 over 2 ln1 plus u minus 3 over 2 ln 1 minus u, that is equals to ln x plus ln c. Now we can move this 2 onto the right hand side, so here we will left with ln1 plus u over 1 minus u cubed, right? And that is equals to twice ln cx, which means that this is now equals to ln 1 plus u over 1 minus u cube is equals to ln cx squared. So it's ln on the both side. We can raise to the power of exponential, which will make it simply 1 plus u or 1 minus u whole cube. That is equals to ln cx squared. Right now, substitute the value of u, that is y over x, and then again 1 minus y over x whole cubed. Right, that is equals to ln c squared. Sorry, now ln is now it is cancelled with this e. This becomes cancel. It become 1 e to the power ln. It's become 1, right? So we're left with c squared x squared. Now if we just simplify this equation, what we will get here is we can take 1 over x outside, so we'll get x plus y over, again here we will get 1 over x cubed outside, we will get x minus y cubed, that is equals to c squared x squared. So this will lift here and it will be x cubed divided by x, it will be x squared times x plus y over x minus y cubed is equals to c squared x squared. And we need to check here that if we are doing each and every step correctly, so this x square cancels. Now we are left with x plus y over x minus y cubed is equals to c squared. Now we have the values, x is equals to x minus h and y is equals to y minus k, where h is equals to k is equals to 1, right? But not always, right? This is fortunately that this is both are equals to 1. So we can substitute here simply x minus h, so it will be x minus 1 plus y minus 1 over x minus 1 plus y minus 1 whole cube is equals to c squared, right? So now it will be x plus y minus 2 over x plus y minus 2 whole cubed. Sorry, this is x minus, so it will be minus and this will be plus, so this will cancel out this one and this one. I'm sorry, that it will be x minus y whole cubed only, like this is equals to c squared. So now finally the answer will be x plus y minus 2 is equals to c squared times x minus y whole cube. So we can leave here, it's the final answer, or if you want to simplify you can simplify the problem, right? So now let's take another example that we are going to solve using uh, some little different technique. Let's say we are given with a problem 6x minus 4y plus 1 dy, and then minus 3x minus 2y plus 1 dx is equals to 0. All right, so we will arrange the equation in terms of dy over dx. That will be equals to 3x minus 2y plus 1 over 6x minus 4y plus 1. Now see here, what's happening here is that dy over dx is equals to 3x minus 2y plus 1. But in the denominator, if we want to take 2 common, but we cannot actually take this 2 common here because it's 1 here and it's 1 here. So we have to solve it using the same approach. That is, we have to solve it using the similar approach that we used earlier by substitution. So this is the problem similar to the problem that we did already. So we have to substitute x is equals to x plus h and y is equals to y plus k, and then similarly we can solve the problem. But what I need to tell here is a problem of a kind. If let's say we are given with the problem dy over dx is equals to x plus 2y minus 1 over x plus 2y plus 1. Right, now see here, x plus 2y and x plus 2y are same in the numerator and denominator. So just simply what I can do here is I can write let u is equals to x plus 2y. So what will happen here, that du or dx will be equals to 1 plus 2 dy by dx, which means du over dx minus 1 is equals to 2 dy over dx, which further implies that 1 over 2 du over dx minus 1 over 2 is equals to dy by dx. So now I can write this problem like this: 1 over 2 du over dx minus 1 over 2 is equals to u minus 1 over u plus 1, right? Because x plus 2y is equals to u, so we can simply substitute like this, and then we can just simplify this one like this: du over dx is equals to u minus 1 over u plus 1 plus half, and then we can multiply like this: du over dx is equals to 2 times u minus 1 over u plus 1 plus 1. Then on further simplification, it will be du over dx is equals to 2u minus 2 plus u plus 1 over u plus 1. Now it's du over dx is equals to 3u minus 1 over u plus 1, which is now separable. Right, so it's u plus 1 over 3u minus 1 du is equals to simply dx. And we can integrate this function easily, so the solution will be u over 3 plus 4 over 9 ln 3u minus 1 is equals to x plus c, which on further simplification we will get 3x minus 3y plus a is equals to 2 ln 3x plus 6y minus 1. So I write it directly. You can use the simplification to solve it, right? So this is the method to solve these problems. And in this problem, we can see here if this is 3x minus 2y plus 1. And this we can write 2 times for this one, 3x minus 2y plus 1. So we can assume, again, we can do here, we can use this approach that I use in the problem, the current problem, that we can assume that u is equals to 3x minus 2y, which implies that du over dx is simply equals to 3 minus 2 dy over dx, right? And then by further simplification, we can write du over dx plus 3 over 2 and 1 over 2 here is equals to dy by dx. And then here we can write 1 over 2 du over dx plus 3 over 2 is equals to u plus 1 over 2u plus 1. And we can solve this problem, right? So this is the method of solving the equations that are non-homogeneous, but we can actually convert or transform these equations to homogeneous differential equations, and then we can solve it by using the method of homogeneous equations, right? So thank you for watching the lesson. Hope you guys will understand the concept behind these type of problems, and in the next lesson we will come up with the exact equations. We'll discuss about exactness and exact equations and how to identify exact equations, and then how to solve these equations, and we will talk about in the next class. Thanks for watching the lesson. Goodbye.